Hello everyone, my name is Greg Black. In this podcast, I will be discussing the boreal forests of south central Alaska. Specifically, we will take a look at the spruce forests of the Kenai Peninsula. In the 1980s, these forests were heavily impacted by an outbreak of spruce beetles, causing widespread mortality of spruce trees across the region. The future of these forests is still in question, and we will take a look at some of the current research to determine fine-scale regenerative patterns across this region. Before getting into the specifics of the forest dynamics, I want to briefly discuss the area of concern. The Kenai Peninsula is located in south central Alaska, just south of the city of Anchorage. It is approximately the size of West Virginia and is often referred to as Alaska's playground. The area receives heavy visitation from tourists and is noted for its scenery and recreation opportunities. The eastern half of the peninsula is mostly comprised of federal land, and the western half is a mixture of federal, state, local, and private ownership. Forest types in the area vary depending on topography and distance to the ocean. The southern coastal forests are true temperate rainforests and are heavily influenced by maritime climate patterns. Stands are usually composed of Sitka spruce and western hemlock, as well as a few hardwood species along riparian corridors. As we move further inland, the coastal climate influences begin to fade, and the forest type changes. In this region, forests are comprised primarily of white spruce and Alaskan paper birch, or Kenai birch. One common element is the existence of hybrid spruce, also called Lutz spruce, a hybridization between white and Sitka spruce. This can comprise a significant portion of the forest type, and distinguishing between hybrids and purebred specimens can often be quite difficult. Birch and aspen have recently become a large component of the local ecosystem, especially with the spruce beetle outbreak. We will review the stand dynamics of this system later in this discussion. The spruce beetle, Dendroctonus rufipennis, is a common forest insect distributed throughout Alaskan forests. Temperature plays a key role in determining life cycles and rates of maturation. Prior to 1980, most spruce beetles followed a 2-year life cycle and would overwinter in the tree boles of mature spruce. During exceptionally cold winters, spruce beetle populations would be lower in the summer. Warmer than average winters result in high summer survival of populations. After 1980, most spruce beetles began to experience 1-year life cycles, reaching adulthood faster than normal. It is widely believed that unanticipated warm temperatures during this period contributed to the shortening of the life cycles. This phenomenon is largely considered to be the reason for the outbreak conditions experienced over the next 20 years. I now want to discuss the stand level changes in vegetation composition after attack. Initially, spruce beetles tend to infest the larger, more mature spruce in the stand. This opens up much of the upper canopy and lowers the average diameter for overstory trees in the stand. This often will release overtop trees and creates gaps in the stand for regeneration. Understory vegetation, including grasses, forbs, and shrubs, tend to dominate the newly developed microsites on the forest floor. It has been observed in some cases these understory plants can outcompete tree regeneration for growing space in gaps created by spruce beetle-related mortality. Often, in areas of high mortality, a permanent new gap can be created because of the immediate competitive exclusion by blue joint grass, fireweed, coastal blueberry, and salmonberry. In some cases, tree regeneration can compete successfully. In large gaps, sprouting from quaking aspen and seedfall from birch can successfully establish on site. Because of the large extent of spruce beetle-related mortality in the region, many of these openings became quite large, and as a result, aspen and birch have become more dominant components of forest structure. The establishment of these species, as well as continued competition from understory species, has severely limited the survival and stocking rates for white spruce on the Kenai Peninsula. Many studies have documented the short-term success of spruce regeneration, but long-term ecological assessments have shown that most of these young trees fail to permanently establish themselves in the overstory. Currently, spruce forests on the Kenai Peninsula are composed of a mix of residual spruce, quaking aspen, and Alaskan paper birch. Most of the surviving spruce was smaller in diameter during the 1980 to 2000 outbreak period and was largely unaffected by spruce beetles. In the long term, many of these hardwood stands will likely be gradually replaced with spruce, but the future of these forests is currently uncertain. The unpredictable hybridization of spruce species contributes to the uncertainty about future forest structure. Methods for improving ecosystem resiliency for future climate change are still unknown. However, the current mixture in these stands does temporarily improve the resiliency to species-specific mortality agents like spruce beetle. To conclude, spruce beetle-related dieback has significantly changed the forest structure dynamics on the Kenai Peninsula. Understanding fine-scale regeneration and growth patterns will be essential to preserving long-term ecosystem health for south central Alaskan forests.